Hello students, welcome to Gate Electronics Guruji classes. In this video we will learn the concept of analog signal and digital signal. We will try to understand what's the difference between analog signals and digital signals, and we will try to remove two very common people's misconceptions in this video. First come to analog signal. Let us look at the definition of the analog signal. It says if there lies at least one interval in the amplitude axis, that is y-axis, such that the signal can attain any value in that particular interval, then the signal is termed as analog signal. Now let me explain what this definition says. The idea is, when you are given the waveform of any signal, look at the amplitude axis or y-axis of that particular waveform. If you can find at least one interval in the amplitude axis such that the signal can attain every possible value in that particular interval, then the signal is said to be analog signal. Let me explain it at a greater depth. Suppose when you look at the y-axis or the amplitude axis of any signal, you find that a particular interval lies in the y-axis, say a comma b open interval, such that the signal can attain every value in this interval. From a to b, if the signal can attain every possible value, then the signal will said to be an analog signal. The interval need not be an open interval, it may be a closed interval, or it may be a semi-open, semi-closed interval. If at least one of these four intervals you can find in the y-axis such that the signal can attain every possible value in that particular interval, then the signal will said to be an analog signal. Now let us go to an example, signal 1. Here I have drawn the waveform of a signal xt sine of omega naught t. This green curve shows the variation of xt with respect to the independent variable time t. First of all, looking at the waveform, you can understand that the signal xt is defined at each and every instant of time t. So clearly this signal xt, which is a sinusoidal signal, is a continuous time signal, right? Because it's defined at each and every instant of time t. Now look at the amplitude axis or y-axis of the signal. You see the minimum value that the signal attains is -1. The maximum value that the signal attains is +1, and in this range from -1 to +1, the signal xt can attain any possible value. When the time t varies from -pi/2 omega naught, this particular point corresponds to -pi/2 omega naught, to +pi/2 omega naught, this point corresponds to t equal to +pi/2 omega naught. You observe when t is varying from -pi/2 omega naught to +pi/2 omega naught, the signal xt varies from -1 to +1, and the signal can attain every possible value in the range -1 to +1. So clearly there lies a particular interval -1, closed interval in the y-axis such that the signal xt can attain every possible value in this particular interval. That's why this signal is a analog signal. So this is a continuous time signal as well as analog signal. So it's a continuous time CT analog signal. Now let us come to this signal, signal 2. The signal is denoted as x of n, and we have drawn the variation of xn with respect to the independent variable n. As you observe that the signal xn is not defined at every instant of time t, Rather, the signal is defined only at some discrete instance of time t. So clearly xn is a discrete time signal. Now observe the amplitude of the signal. At n equal to 0, the amplitude is 1. At n equal to 1, the amplitude is 1.5. At n equal to 2, it is 0.5. At n equal to 2 to 3, the amplitude is -1. At n equal to 4, the amplitude is 2. At n equal to -1, the amplitude is 1.7, etc. Keep in mind that this signal xn actually extends from n equal to -infinity to n equal to +infinity. We have drawn the waveform of the signal only when n is varying from -4 to +4. This doesn't mean that the signal xn is only in this interval n equal to -4 to +4. Rather, the signal is extending from n equal to -infinity to +infinity. We have drawn the waveform of the signal only in this particular range of n, from n equal to -4 to n equal to +4. Now observe. You see that in this particular interval -4 to 4, the amplitude that the signal xn attains are very abrupt. It can take 1, 1.5, 0.5, -1, 0.7, 2.1, 1.7, -1.2. The amplitudes of signal xn are very abrupt, right? So if you think of this particular signal extending from n equal to -infinity to +infinity, you can clearly understand as the amplitudes attained by the signals are very, very random. So clearly it can take any possible value when n is varying from -infinity to +infinity, right? Just observing the signal's amplitude from -4 to 4, you can intuitively understand that the amplitudes attained by the signals, this particular signal is very abrupt. That's why if you think of the amplitude of this signal when n is varying from -infinity to +infinity, clearly xn can take any possible value, right? Because the amplitudes that it takes are very random, right? That's why there will obviously be at least one interval a comma b such that the signal xn can take every possible value in this interval. You can intuitively say this clearly. Alright. So as the signal can attain every possible value in this interval a comma b, so clearly xn is an analog signal. Just observing the signal from n equal to -4 to 4, it feels like it can take only some discrete values, but you observe that the values or the amplitudes of the signal are very random. So if you think of this particular signal extending from -infinity to +infinity, you can clearly, with 100% accuracy, you can intuitively say this, that the signal xn can take any possible value in at least one range. Say the range is a comma b. So clearly this is an analog signal. So though this signal is a discrete time signal, but it's an analog signal. So it is a discrete time analog signal. So from here I can make a conclusion that analog signals can be continuous time or discrete time. There are many students, as well as I have seen in my life, there are many professors who actually teach in the class that continuous time signals are always analog. But that is not the case. Analog signal can be both continuous time as well as discrete time. The misconception that the analog signals are continuous in time domain arises because most of the signals that we obtain from nature are simultaneously continuous time as well as analog. But that doesn't mean that the analog signal needs to be only continuous in time domain. They can also be discrete in the time domain. So here is a note that the analog signal, the amplitude axis is continuous, that is non-discretized, but the time axis may be continuous or may be discretized. Clearly in an analog signal, as the h there is at least one particular interval, say comma b, such that the signal can attain every possible value in that interval. So clearly the amplitude axis is continuous or non-discretized, but the time axis may be continuous or may be discretized. If the time axis is continuous, then the signal will be a continuous time analog signal. If the time axis is discretized, then we will have a discrete time analog signal. I hope it's clear up to this part. Now let us go to digital signals. How do we define digital signal? If a signal can attain only a discrete set of values, then the signal is termed as a digital signal. In an analog signal, we observe that at least one interval lies in the amplitude axis such that the signal can attain any value in that particular interval. Now we know that in a particular interval, say a comma b open interval, between a and b infinite number of real values lies. So analog signal can take infinite number of possible values. But in a digital signal, the signal can take only a discrete set of values. There are only a finite number of values that the digital signal can attain. So though an analog signal can attain infinite number of possible amplitudes, a digital signal can attain only a finite set of amplitudes, only a finite number of values. Now let us go to this example, x of t. Achha, first let us come to this example, then we will go to this example, okay? You observe that we have a signal xn. Clearly xn is a discrete time signal because xn is defined only a discrete instance of time t. Clear up to this part? So xn is a discrete time signal. Now observe the amplitude of the signal. You observe that when n varies from 0 to 4, the amplitude is continuously 1. When n varies from 5 to 9, the amplitude is -1. And this particular signal actually repeats itself from n equal to -infinity to n equal to +infinity. So clearly this is a periodic signal. But you observe that the amplitude that xn can take has only two possible values. It can either be +1 or it can be -1, right? So xn can take only a discrete set of values. Here it can take only two values, -1 and +1. Okay? So clearly this is a digital signal, but it's a discrete time signal. So it's a discrete time digital signal. Now let us come to this signal, this one. You observe that xt is a continuous time signal because xt is defined at each and every instant of time t. But you observe that xt can take only two possible values. It can either be +1 or it can either be -1. This particular structure actually repeats itself, right? So as xt can take only two possible values, +1 and -1, I can say that xt is a digital signal because it attains only a discrete set of values. So though this signal is a continuous time signal, but this is a digital signal. So this is a continuous time digital signal. So from here you can conclude that digital signals can be both continuous in time domain or discretized in time domain. A misconception lies among many students and professors I have seen in my life that digital signals mean discrete time signal. No, digital signal can be both continuous time as well as discrete in time domain. The misconception arises among the professors as well as the students. I have seen many professors making these mistakes. The reason is very simple. Most of the digital devices that we use nowadays actually use discrete time signals because discrete time signals are actually more easy to operate on. That's why they think that digital signal means discrete time signal. That's not very necessary. Digital signal can be both continuous in time domain as well as discretized in time domain. So I hope it's clear up to this part. So I have written this in a note form. In digital signal, though the amplitude axis is discretized, but the time axis may or may not be discretized. The amplitude axis is discretized because in these signals, the amplitude cannot have any abrupt value. It can only attain some discrete values. That's why the amplitude axis is said to be discretized. But the time axis may be discretized or may not be. If the time axis is discretized, then we will have a discrete time digital signal. If it is not discretized, that is if the time axis is continuous, we will have a continuous time digital signal. So I hope that you understand up to this part. So a quick revision, what we learned that analog signal can be both continuous in time domain or discretized in time domain. Similarly, digital signals can also be both continuous in time domain as well as discretized in time domain. So I hope the concept is totally clear, and if you have any doubt up to this part, let me know in the comment section. And if you think you are genuinely liking my videos, then I will request you to subscribe to my channel, because it's your likes, your comments, your subscriptions to my channel that actually motivate me to make more and more videos for you. Thank you.